to configure IP, right, on the PC. How you will configure the IP, guys? DHCP is the one method to configure IP on end devices. Let's say you need to configure IP manually in Windows 10 or Windows 11. You know how to do it, how to configure it. Okay, so like that we can configure the IP over here, that is, let's say 10.10.10.1, and IP address on PC2 is, let's say, 10.10.10.2. Done. Now can these two computers communicate with each other? Answer is yes. Both are in same subnet. So to communicate with each other, both devices need what, guys? Address first. And if computer A, means computer 1, want to communicate with computer 2, computer A need four things. First, source MAC address. Second thing, destination MAC address. Third thing, source IP address. And fourth thing is destination IP address. Yes or no? In the same way, if computer B want to communicate with computer A1, computer 2 also need these four information, right? So if you are going to send some data from PC1 to PC2, you are going to provide IP address of destination device to PC. Means who will tell to PC1 what is the IP address of PC2? You, right? And with the help of protocol, PC1 is going to find the MAC address of PC2. With the help of protocol, PC1 will find the MAC address of PC2. That protocol is R protocol. We will learn R protocol later. So R stands for Address Resolution Protocol, right? It's clear with their name, Address Resolution Protocol. Whenever a device have information of IP address and they want to find MAC address, right? Like PC1 have source IP, PC1 have destination IP. Yes, because you have tell to PC1 the destination IP address is 10.10.10.2, right? Like I want to ping PC2 from PC1, so in the CMD I will run this command, ping 10.10.10.2. so PC1 will get to know, okay, destination IP address is this one. Now PC1 need what? Destination MAC, because source IP is there, source MAC is there, destination IP is there, but destination MAC is still unknown. Yes or no? So this PC is going to call R protocol. It will say, hey R, do one thing, just find the MAC address of this IP address 10.10.10.2. Then R protocol is going to resolve the MAC address of 10.10.10.2, right? R protocol is going to tell to PC1, see, MAC address of PC2 is 0B. Now PC1 have all information. It is going to encapsulate the data, right? So with the actual data, he is going to add source IP, that is 10.10.10.1, destination IP 10.10.10.10.2, source MAC 0A, destination MAC 0B. Done. And after that, PC1 can hand over it to NIC port. Then you can forward traffic from the NIC, right? So actually, you know what this PC is going to check? This PC will check, okay, destination IP address is 10.10.10.2, right? So again, this PC is going to check that this IP address means network, that this network is running on which interface, right? Let's say on this PC there are multiple NIC, NIC1, then there is one more NIC, that is NIC2, right? Guys, on NIC1, which network is running? 10.10.10.0/24, and on NIC2, let's say 20.10.20/24. 10.10.0/24 network is running. So from which NIC PC1 is going to forward data? From NIC1 or NIC2? So it will compare the destination IP address with their route. So this PC have two route, right? One is this network and another one is this network. But destination is matching in this network, right? Which is running on NIC1. So it will forward traffic from NIC1. Yes? Is it clear to everyone? Like guys, see here in my CMD, here I have multiple interfaces, right? On this PC. I have multiple interfaces like you can see Ethernet adapter 3. Which network is running over here? 192.168.50.1. On Ethernet 3 port, this network, this IP address is running. That means network is subnet mask is, you can see this one, 255.255.255.0. That means network ID is what? 192.168.50.1. 50.1, right? This network and network ID is 50.0. 50.0. This network is running on Ethernet 3. Ethernet 3. This is just name of your NIC. Then guys, I have one more interface. Here you can see this one. Wireless LAN adapter means local area connector 1. And which network is running over here? DHCP is enabled, but you can see on this interface we don't have any IP address. But guys, on this interface we have one IP, right? That is this one, 169.254.25.212, and subnet mask is this one. That means network ID of this IP address is going to be this 169.254.0.0. This network is running on VMware 1. In the same way, I have one more interface. You can see here VM8 wireless LAN. I have one Wi-Fi NIC here on, and which network is running over here? This one, 192.168.1.0/24, and this network is running on Wi-Fi interface. Now see, we have 3 NIC on my laptop. If this laptop need to forward a packet to 192.168.1.5, right? So if I am pinging this IP address, simply what I will do, I will type this IP address in the command. So you tell me this PC is going to forward packet from which interface? From which NIC? 192.168.1.5. So once I will hit enter, this PC is going to compare this IP address with their all entries, right? And you tell me guys, this IP address is matching in which network? Yes, so it will forward traffic to my wireless router. But if I'm pinging 192.168.50.5, then it will forward traffic from Ethernet 3 NIC, correct? Is it clear now? Tell me everyone. So this is the IP address. In the subnetting, brother, you will learn how to find the network ID of this IP address. This IP address is running on this interface, right? On the Wi-Fi NIC. So this is the IP address and we have subnet mask. So with the help of IP address and subnet mask, we can calculate the network ID, right? We will use the algorithm, and my machine already know that algorithm. This machine have already information about that algorithm. So once you will configure this IP address on the interface, it is going to calculate the network ID, and it will store it in the routing table. So your Windows machines also maintain routing table. Okay. So this is an IC card network interface card, and it is important. So we talked about this hardware yesterday. Then guys, next device was hub, right? So why we need hub? See, here we have two PC and both have one NIC. So we can connect both PC together. But let's suppose we have multiple computers, more than two, and both machine have single NIC. Then guys, can you connect those all devices together? Means 5 computer or 10 computer, more than 2 computer? Not possible, right? Like this. Suppose I have computer 1 here, computer 2, computer 3, and computer 4. Both have one NIC card. One over here, one over here, one over here, and one over here. I want to make communication between these all devices. Is it possible to connect them together directly without using a centralized device? It's not possible. Why it's not possible? Because see, PC1 have only one NIC port. So either we can connect PC1 to PC2 or PC3, PC4. Means I can connect this to only one another more networking devices. Means one other networking devices. Either I can connect PC1 to switch 2 or to switch PC3, PC2 or PC3 or to switch. But we cannot connect these all computers directly with each other. Clear guys? So we need a centralized device here and we come up with which device first? Hub. So hub was the centralized device to connect multiple networking devices together. Correct? Hub was the networking device used to connect multiple computers together. And now hub will have multiple ports here. And all ports are, as I told you in last class, all ports are directly connected with each other. So that's why hub can only perform broadcast. Hub don't have capability to perform unicast. Means two devices cannot communicate with each other securely. There is no security. If one device is forwarding traffic to another device, hub will forward it to all other devices as well. And now guys, tell me which type of network it is. It is a local area network, LAN. Correct? So tell me the problem with hub guys. First problem is always doing the broadcast, no privacy, right? Hub don't have memory. It's work on hub duplex. So that's why we come up with another device. Which device? Switch. Okay. So again, switch is used to connect multiple networking devices together. Hub is also used to connect multiple networking devices together. But the difference is switch has memory. Switch has operating system. Switch can read the data. Switch can do unicast, multicast as well as broadcast. Right? And switch works on full duplex. Means at a time, switch interface can receive the traffic as well as send the traffic, transmit the traffic. But in case of hub, either you can send the traffic or you can receive the traffic at a time. Yes or no? So, yes, brother. In hub, we cannot do both things at a time, right? Yes. Yes, it works on hub duplex. Now with switch, let's suppose I have multiple computers. Computer A, computer B, C, and D. Let's suppose these are MAC address of computers. And these all devices are connected through this switch. So first of all switch port will have one port ID number. So let's say port ID of this interface is 0/1, 0/2, 0/3, 0/4. Guys, what is the meaning of 0/1? Anyone? Yes, slot and port. 0/1 means slot number 0 and port number 1. Like guys, I have this switch. right? This is box I have purchased from the market, and there are four slot. There are four slot. Can I use this switch now? No. To use this switch, I need to insert the card over here, right? So I will insert the card, then I will get port over here like this. Port number 1, 2, 3, 4, 5. Again here I have 5 ports, let's say 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now how many ports I have on this switch? 20, correct? And this is my slot number 0. This is slot number 1. This is slot number 2, slot number 3. Then what will be the interface ID of this port? 0/1 means slot number 0, port number 1. What will be the interface ID of this port? 3/1 means slot number 3, port number 1. So if I am saying 0/1, that means I am talking about slot number 1, and under the slot number 1 I am talking about the port number 1. Clear? Okay. So see, first of all, what will happen in case of switch? Whenever this switch is going to receive any traffic on 0/1 interface, guys, in the all traffic on 0/1 interface, source MAC will be what? See, this switch is going to receive traffic on 0/1 from this PC only every time. Yes or no? Right? Every time this switch is going to receive traffic from PC A only. So source MAC will be always what? A, right? Even let's say PC1 is forwarding traffic to PC B, source MAC will be A, destination MAC B. When PCF is forwarding traffic to PCC, source MAC will be again A, destination MAC will be C. So doesn't matter this PC is forwarding traffic to whom? To internet, to router, to other PC, to printer, IP phone. Every time source MAC is going to be what? A only. Yes or no? Right? So whenever this switch will receive traffic on 0/1 interface, this switch is going to learn source MAC address. It will get to know that okay, one device is connected on this port whose MAC address is A, right? So let me do one thing. Let me maintain one table. This switch is going to start maintaining a table. That table is called MAC address table. MAC address table, right? And it will make one entry in their MAC address table that on my 0/1 interface a device is connected whose MAC address is what? A. Getting my point? Once this switch will receive any traffic on 0/4 interface, again it will learn the MAC address that on my 0/4 interface a device is connected whose MAC address is what? D. And with the help of this table, this switch can perform unicast. So always keep in mind this behavior of switch. This is by default behavior, right? So always keep in mind whenever switch will receive any frame on the interface, the first thing that switch will do is it is going to learn the source MAC address. It is going to learn the source MAC address. Okay, so now again let's come to this diagram. Yes, any question? Yes, yes. Hmm. No, it's depends on your switch, na brother. Your switch can have 2 slot, 4 slot. Your switch can have even a single slot. Let's say on the switch I have single slot, and that slot, in the slot I can put card of 24 ports or 48 ports. Right. Then port is going to be, last port will be 0/24. If there is only one slot and we have 48 ports, then first port will get what port ID? 0/1. Last port will get what port ID? 0/48. Got it? Hmm? That is, yes. So this is my switch, and I have some computer, PC1, PC2, PC3, And let's say PC4, only I have 4 PC. Right? So PC, this is, let's say PCA, whose MAC address is 0A. PC1 MAC address 0A. PC2 MAC address 0B. PC3 MAC address 0C, and PCD MAC address is 0D. PC1 MAC IP address is, let's say, 10.1.1.1. PC2 IP address is 10.1.1.2. PC3 IP address is 10.1.1.3, and PC4 IP address is 10.1.1.4. Clear? This is 0/1 interface. This is 0/2 interface. This is 0/3, and this one is 0/4. Done, guys. Now PC1 want to communicate with PC2. Let's say this is PC1, PC1, PC2. Just I am numbering it to make you understand the concept. PC3 and PC4. So guys, you tell me, if PC1 want to communicate with PC2, or let's say PC4, what will be source IP address? PC1 10 dot, destination IP will be what? PC4. Let's say PC1 want to communicate with PC4, then 4. Source MAC will be what? 0. Destination MAC will be what? 0D. How it will get destination MAC? With the help of R protocol. We will see it later. Right? Now, after that, this PC will forward this data to switch. Right? It will out from their NIC. Means from this port. Then guys, switch is going to receive it. Switch will receive this data on which interface? On 0/1 interface, correct? MAC address table. So on switch will receive traffic on 0/1 interface. What it will do first thing? It is going to learn source MAC. First function. Right? It will learn source MAC. It is going to make one entry in their table, MAC address table, that on my 0/1 interface, which device is connected? 0A. Means device who is using this MAC address, right? After that, the next task of switch is, first task is, here I am writing task of switch. First task, learn source MAC address. Second task, second thing, he is going to check the destination MAC address. So what is destination MAC address, guys? 0D, destination MAC. Switch forward traffic on the basis of MAC address only, right? Switch is not going to check IP address. So it will check the destination MAC. Destination MAC is 0D. Again, switch will look up their MAC address table. Why? Just to know the exit interface for 0D MAC address. So switch is checking, do I know the interface for this MAC address, 0D MAC address? So is there any entry, guys? No, in the MAC address table. There is no entry. Then switch is going to perform a non-unicast flooding. This is not broadcast. A non-unicast flooding. A non-unicast flooding means forwarding traffic from their all interfaces except the receiving interface. So except this receiving interface, switch is going to forward one copy from here, one copy from here, one copy from here. This is again what? Broadcast. Same thing switch is also doing like hub. Yes or no? But guys, just try to understand why switch forward one copy of data from their all interfaces. Because switch don't know the interface for 0D MAC address, right? For PC4. So what will happen when PC2 will receive the frame? PCB is going to check destination MAC first. So destination MAC is what? 0D. And my MAC address is what? 0B. So PC2 will get to know this is not for me. PC2 is going to drop it. Same thing when PC3 will receive the packet, PC3 will check the destination MAC. Oh, destination MAC is 0D. My MAC address is 0C. This is not for me. PC3 is also going to drop it. Then PC4. PC4 will check destination MAC. Destination MAC is 0D. And my destination MAC is also what? 0D. So at layer 2, this PC will get to know, yes, this frame is for me only. Then this PC is going to check destination IP address. So again it will check destination IP and my IP both are same or not. If both are same, then only I will accept it, otherwise I will discard it. So both are same. Destination IP is 10.1.1.4 in the frame, in the packet, and my IP address is also 10.1.1.4. That means yes, this packet is for me, right? Now this PC is going to generate what? Reply. This PC is going to generate reply. So when this PC will generate reply, you tell me what will be the source IP address? When PC will generate reply, guys, what will be source? 10 dot 1 second 10.1.1.4 destination 10.1.1.1 source MAC 0 destination MAC 0A. Then this PC will forward it to switch, right? Switch will receive this frame on which interface? 0/4. So first thing what switch will do? It will learn source MAC, yes or no? So switch is going to make one entry here that on my 0/4 interface, a device is connected whose MAC address is 0D. The next task of switch, next task is packet forwarding. Check the destination and exit it from interface, from the correct interface, you can say. Correct. Second task. So again, first it will learn the MAC, source MAC. After that it is going to check destination MAC. So destination MAC is what, brother? 0A. So again switch is going to look up their MAC address table, and this time yes, there is one entry, right? 0A MAC address device is connected on 0/1 interface. So this time it is going to forward frame from this interface only. So this is what? Which type of communication? Unicast. Now this switch have information that on 0/1 interface a device is connected who is using 0A MAC address, and on 0/4 interface a device is connected who is using 0D MAC address. So whenever this switch will receive frame where destination is 0A, switch is going to forward it from this interface only. Whenever destination MAC is 0D, then switch is going to forward it from this interface only. Clear, guys? Basic function of switch. How switch forwarding data? Tell me frankly. If any question, let me know. Now there switch is going to run one timer over here, right? After a specific time, this switch is going to flush the entry, right? We'll talk about those timer, brother, don't worry. But this is it clear? Right? How switch is going to forward data? Or interviewer can ask you this question like which table switch maintains to forward data, so MAC address table. How switch build MAC address table with the help of source MAC address. Whenever switch will receive data, it is going to learn source MAC address, right? And on the basis of destination MAC address, it is going to take forwarding decision. And again, there's two things. If there is entry in the MAC address table for destination, then switch is going to perform unicast. If entry is not available in the MAC address table, then switch is going to perform a non-unicast flooding, right? A non-unicast flooding means forwarding the frame from their all interfaces except receiving interface. All clear? No question till here? Sorry, how? How many packets? One packet. One packet from this interface, one packet from this interface. Let's say this switch is receiving a frame where destination is 0E. Is there any entry available in MAC address table? No. So it will forward from their all interface. Let's say this switch have 48 ports. So it is receiving frame on one interface. That means this switch is going to forward it from rest 47 ports. Getting my point? Now again there is concept of VLAN. With the help of VLAN we can divide this switch. So if I have created the VLAN, if these two ports are member of different VLAN, if these two ports are member of different VLAN, then traffic of this VLAN means, let's say this is VLAN 10 and this is VLAN 20. So traffic of VLAN 10 will be flooded in VLAN 10 domain only, right? Don't worry, we will discuss the VLAN and make you understand these all concept, guys, very carefully. But first try to understand the basic fundamental of switch. How switch is learning MAC address and how switch is maintaining MAC address table, means building MAC address table. Is it clear? Okay. Okay. No, for PC, one switch is not going to perform a non-unicast flooding because switch have already information, the MAC address of source as well as destination. When PC B will forward traffic to PC4, PC2 will forward traffic to PC4. It is going to learn source MAC over here. Source MAC, see, when PC2 will ping to PC4, source MAC will be 0B, destination MAC will be 0D. So when switch will receive the frame, it is going to learn 0B MAC address. On which interface? On 0/2 interface. After that, switch will check what destination. Destination is 02. Is there any entry available? Yes, entry is available. The exit interface is 04. So it will out traffic from 0/4 interface. There is no non-unicast flooding here. Okay. अगर 0D नहीं है टेबल में तब तो अननोन यूनिकास्ट फ्लोटिंग होगा पहले, अगर है ही तो होगा ही नहीं ना, अगर नहीं है तो फिर होगा ना नॉन यूनिकास्ट फ्लोटिंग। बिल्कुल। एंड जो PC2 ने जनरेट किया था वो PC1, 3 और 4 के पास जाएगा, राइट? एनी अदर क्वेश्चन? No, no, on all Wellnut devices, brother. Okay. So let me do one thing. Let me perform on a small lab of it. Wait a second. Okay, so I am going to use any switch here just to perform this lab. So let me use this one. This is 29503 switch, and let's suppose I have some PCs here, guys. See, when I will configure IP address on PC, can anyone tell me switch will run MAC address or not? When I will configure the IP on PC, guys, will switch get MAC address of PCs? How? See, for now, yeah, this is access of switch. Don't worry, we will talk about the modes, guys. Here, like I am running enable command. If anyone don't know why we are running enable command here, we will talk about the modes of these devices. For now, I am going to check show MAC address table. Command to check MAC address table is show MAC address table. And guys, is there any entry available? No. So switch is going to maintain how many things under MAC address table? First is MAC address of device, then port number, on which port number that MAC address is connected. After that, type. Because see, we have two options to configure MAC address or to bind MAC address with interface. One is dynamic, another one is static. Manually, I can tell to switch that brother, please note down this MAC address on that particular interface, right? And after that, VLAN information, VLAN ID. So we will talk about the VLAN later. So right now, this switch don't have any MAC address in their MAC address table, correct? Okay, guys. Now, I am going to configure IP on this PC0. PC0, let's say IP address is 10.1.1.1, subnet mask is 255.255.255.0 or 255.0.0.0 live. Okay, so I have configured the IP here. How to check MAC address of this PC? Here is the MAC address. This is MAC address of this PC. Let me write it over here. Okay, is MAC address visible to everyone? MAC address of PC0. Right. So this switch is going to learn this MAC address on which interface? On 0/0/1. So MAC address table. Is there any entry, guys? This time? One entry is there, right? Is it MAC address of PC0? And how this machine have learned it? Dynamically. And on which interface? On 0/1 interface. That means now whenever switch is going to receive a frame where destination will be this one, then switch is going to forward it from 0/1 interface always. Yes or no? FA0 means fast Ethernet. This is interface type. In the network fundamental, we will learn interface type as well, right? We have multiple types of interface type. So this is fast Ethernet interface. Fast Ethernet will provide you 100 Mbps throughput. Means this port can receive data of 100 Mbps and send 100 Mbps data at a time, right? Means throughput is going to be 200 Mbps. right? Like if you want to increase the throughput, you can use what? Giga interface port. But on this switch, guys, we don't have giga interface port. We have only fast Ethernet ports. Yes, tell me. We'll discuss the interface type as well. Don't worry. Clear? Yes. When see till now PC have received traffic on one interface, on 0/1 interface. So it have learned the MAC address, right? In the same way, when this switch is going to receive traffic on this interface 0/2, it will learn the MAC address. When it will receive traffic on this interface, it will learn MAC address. When it will receive traffic over here, it will learn the MAC address. Until and unless switch is not going to receive any traffic, it will not learn MAC address. Or manually, you can check the MAC address of PC 0 is this one. Now I can manually configure this MAC address on this interface. Getting my point? Now question is, I have not sent any traffic to switch from this PC, right? Then how switch to PC to switch? Then how switch have learned the MAC address? Yes or no? Because I have only configured the IP address here, right, guys? And automatically switch have learned the MAC address. So what is happening actually? Whenever you are assigning IP on port, first thing that device will do is it will check duplicacy. That is this IP address duplicate or not? Is it unique or not? Right? So let's say here I have assigned what IP, guys? 10.1.1.1. So first PC need to check that this IP address is unique or not. If someone else is using this IP address, then this PC is not going to accept it. So what this PC will do, once we will assign this IP on their interface, first of all this PC is going to generate a message, right? Actually one protocol is going to work over here. That protocol is called GARP, gracious ARP. GARP. GARP is a protocol which is used to check duplicate IP address. What I am saying? Gracious ARP is a protocol which is by default running on all devices, and it is used to check IP address, that IP address is unique or not. So it is going to generate one GARP packet, GARP packet, and then source IP is going to be 10.1.1.1. What will be the destination IP? Same, 10.1.1.1. So guys, tell me who will generate reply for this traffic? The device who is using this IP address, right? Let's say PC3 is using this IP address 10.1.1.1. Then PC3 is going to reply, right, to PC0. And here source MAC will be the MAC address of PC0, this one, and destination MAC will be broadcast, means all F. So this PC is going to forward this packet to all devices in the network, so that if anyone is using this IP address, then that device will generate reply. And once this PC will send this packet to switch, it will start one timer and it will wait for some time. If it will receive the reply message within that time, then it will reject the IP address, right? Then this PC will get to know, no, this IP address is not unique. If it will not receive the reply, then this PC is going to assign the IP address on their interface. So what is happening in my scenario, once I have assigned this IP address on PC0, it have generated the gracious ARP, it have set the source IP, destination IP, source MAC, destination MAC, then it have forwarded to switch. So this is why switch have learned the source MAC, right? Because of gracious ARP. Getting my point, guys? So on switch will receive the gracious ARP, first it will learn source MAC address on 0/1 interface. After that it will check destination. Destination MAC is all F, means broadcast. So it is going to forward one copy from their all interface. Clear? Okay. So in the same way, when I will configure IP on PC2, PC1, PC1 is also going to generate gracious ARP, and on switch will receive gracious ARP, it is going to learn MAC address. Once I will assign IP on PC2, switch will learn MAC address on 0/3. Once I will assign IP on PC3, it will learn MAC address on 0/4 interface. Got it? Is it clear? Yes. Now, so let me take you to PC1, and on PC1 I am going to configure IP 10.1.1.2. Done. And PC2 MAC address is this one. Let me copy the MAC address also. This is MAC address of PC1. Now you can check the MAC address table of this switch. This switch will have how many MAC addresses? 2. So I can run CMS command, show MAC address table. So why we have only one MAC address, guys? It have removed the previous entry. It have removed the previous entry. Yes, timer is expired. For the MAC address on 0/1, timer is expired, that's why you have flushed the entry, right? Now until and unless switch will not receive any traffic on 0/1, it will not learn the MAC address of PC0. In the same way, let me assign IP on PC2, and PC2 IP address is, let's say, 10.1.1.3 255.0.0.0. Then go to PC3, and let me assign one IP on PC3 also, 10.1.1.4. Done. Now let me take you to switch and see the MAC address table, right? It have learned MAC address on all the interfaces, right? Now guys, I am going to clear MAC address table. I can run command clear MAC address table like this. Again, you can check show MAC address table. Is there any entry now? Is there any entry, guys? No. It is very important, because while I will teach you switching protocols, guys, basic fundamentals should be clear to you. Yeah, my voice is breaking. Is it for everyone? Hello? Right now it's fine? Or still voice is breaking? Right now it's good. Now guys, here I am going to use simulation modes to see the packet. See, PC0 IP address is 10.1.1.1. PC1 IP address is 10.1.1.2. PC2 IP address 10.1.1.3, and PC3 IP address is 10.1.1.4. Done. Now you tell me, if PC0 want to ping PC3, PC0 want to ping PC3, source IP will be 10.1.1.1, destination IP will be 10.1.1.4, source MAC will be the MAC address of PC0. Source MAC will be the MAC address of PC0, and destination MAC will be the MAC address of PC3. But PC0 have MAC address of PC3. So see, PC store MAC address with IP address in their ARP table. So all the devices, once you will configure IP on PC on Windows 10 or 11, these devices will start maintaining one table. That table is called ARP table. And how to check ARP table? Just run this command, ARP -a, this one. So is there any entry available, guys? No. No ARP entry found. So this PC don't have any MAC address. So PC0 don't know what is the MAC address of 10.1.1.4. So if I will ping 10.1.1.4 from here, what will happen? ping 10.1.1.4. Voice is breaking. I think internet is working fine. एक बार इंटरनेट चेक करना, इंटरनेट चल रहा है बराबर, स्पीड चेक करो। कल इंटरनेट वाले को बोलो स्पीड के लिए बढ़ाने के लिए, उस रूम वाला वाईफाई इधर लगा देगा। कम पड़ रहा है। Guys, today we have to manage. Tomorrow I will change the provider, internet provider. Okay, so see, I am going to ping from PC0 to PC3, means 10.1.1.1 want to ping 10.1.1.4, but this PC don't have MAC address of destination device. You have till the destination IP address. The destination IP is 10.1.1.4. This PC already have source MAC, source IP, but one thing is missing, that is destination MAC. So once I will hit enter over here, you can see this PC have generated two packet. One is ICMP and one is ARP. ARP means address resolution protocol to find the MAC address of 10.1.1.4. You can see this is ARP packet. If you will open this packet, brother, see the information here. Source IP. What is source IP here? 10.1.1.1. Is it visible, guys? Is it visible? Source IP 10.1.1.1. Destination IP 10.1.1.4. Target IP address. Right? Source MAC is the MAC address of PC0. Yes or no? Yes. Destination MAC unknown. 0 means unknown. I don't know. Who is going to generate reply for this packet? 10.1.1.4. Yes or no? 10.1.1.4 is going to generate reply. So this PC is going to forward this ARP to switch. Now switch will learn MAC address. First thing, switch is going to learn MAC address. You can see here, right? Now switch will check what destination MAC. So destination MAC is unknown. Then this switch will forward it from their all interfaces except receiving interface. So see, it is forwarding to all. PC1, 2 will drop it. Yes, you can see these two are discarding. Why? Because target IP address is 10.1.1.4. So PC2 IP address is 10.1.1.1. It will discard it. PC2 IP address is 10.1.1.3. It will discard it. But PC3 IP address is 10.1.1.4. So destination IP means target IP and the IP address of PC3 is matching, right? So PC3 is going to generate what? Reply. Right? And guys, in the reply message, what is source IP? 10.1.1.4. PC3 IP. Destination IP 10.1.1.1. Source MAC address of PC3. Destination MAC address of PC0. So you can see this PC is sharing their MAC address, right? This PC3 is sharing their MAC address. So it will forward to switch. Now again switch will learn source MAC address. After that, this time tell me switch is going to perform unicast or broadcast? Unicast, because destination MAC is MAC address of PC0 and it have already information, right? This time switch will have two entry. Right, one on port 0/4 and one on port 0/1. So entry is already there, so it will perform unicast. It will forward the ARP reply message to PC0. Now PC0 have MAC address of PC3. Now this PC can forward actual message, right? Because to forward actual message, source IP, destination IP, source MAC, destination MAC, these four things is required, right? So destination MAC was missing, but ARP has resolved the destination MAC. Now this PC is going to forward actual ICMP traffic. How? Unicastly, because switch have entry for both MAC address, right guys? And now you can see ping is working fine on this PC. And now if you will check the ARP table of PC, like ARP -A, so you can see there is one entry, right? What is the MAC address of 0/110.1.1.4, guys? This one, right? And how this PC have learned this MAC address? Dynamically. And this PC is going to store this information for 4 hours. Getting my point? Clear? So now next time when PC is 0 will, yeah. So see, I have typed what, brother? In the CMD, just I type ping 10.1.1.4, correct? I will hit enter. Once I will hit enter, your PC is automatically going to generate some data, right? Some kind of packet to forward PC3. Yes or no? Right? So how this PC is going to generate data or traffic? With the help of protocol. Because in the whole networking, to do any task, we have only two options. One is manual and another one is dynamic. So in manually, network engineer will configure or do it, but dynamically, protocol are responsible, right? Whatever task you can perform, same task can be performed with the help of protocol as well. So here, this PC is generating traffic automatically. That means one protocol is running behind the scene, and that protocol is called ICMP protocol. So ICMP is a protocol which is used to check connectivity between two devices, right? Ping is nothing. Ping is just a utility which is used to check connectivity, but this ping need a protocol who is going to generate the traffic. Okay, so we will talk about ICMP protocol later, right? ICMP is a protocol which is responsible to generate ICMP request message and reply message. ARP is different protocol. ARP is responsible to resolve MAC address from IP address. Whenever you know the IP address, destination IP address, but you don't know the destination MAC address, so you will call to ARP protocol. Hey ARP, please resolve the MAC address of this IP address. But ICMP is a protocol which is used to check connectivity, to generate traffic. Which type of traffic? ICMP request message and reply message. So on both PC0 and PC3, ICMP protocol is running, guys. So if I am pinging the IP address of PC3 from PC0, at PC0 ICMP protocol is going to generate request message, and on PC3 it is going to generate reply message. Just give me 1 minute. 1 minute. Yes. Anyone have question? Please ask. 00 means unknown. 00 means unknown. All F means broadcast. ARP request. Again, in the ARP we have two messages, ARP request and ARP reply. Like this PC don't know the destination MAC, so this PC will generate ARP request, and this PC is the destination device who need to share their MAC address, so it will generate ARP reply. ARP reply. Broadcast means forwarding traffic to all devices. Broadcast means forwarding traffic to all devices, but here destination MAC is unknown means who is using this IP address 10.1.1.4? Who is using this IP address? Please tell me the MAC address, because MAC address of this IP address is 0000 means unknown. So on PC3 we'll see, okay, destination MAC is 000. That means this MAC is unknown. Let me resolve it. Let me see my MAC address to the source. Who is the source? 10.1.1.1. Getting my point? So broadcast is different thing. Broadcast is when I want to forward a traffic to all computers. When I want to find the MAC address, that time I don't need to do the broadcast. Yes. Let's say this PC need to forward traffic to, PC0 need to forward traffic to PC3. And this PC even don't know what is the IP address of PC3. Then definitely this PC have to do what? Broadcast. Just remember gracious ARP. Why gracious ARP was broadcast? Because this PC is checking, is this IP address duplicate or not? So this PC need to ask to everyone, right? So it will do broadcast. Getting my point? Switch is going to treat unknown packet, means if destination is unknown, and broadcast. Switch is going to treat in same way. It is forwarding one packet from their all interfaces except receiving interface. Switch will treat both as the same, but there is difference. Unknown means I am looking for the MAC address, and broadcast means I am forwarding it to everyone. Got it? ऐसा भी बोल सकते हैं हम, क्यों नहीं? Okay, let me open this lab. Let's say. How many switches I have, guys? 2. Right? So switch 1 will learn MAC address of PC1 on which interface? On 0/2 interface. And MAC address of PC3 on which interface? On 0/3 interface. Right? So let me check PC1. PC1, PC3. I'm going to configure one IP on PC1. Configure T interface F0/0, say no set, and IP address 10.1.1.1 255.255.255.0. Okay, I've configured this IP address over here 10.1.1.1. Okay, so IP ARP. See the difference between ARP table on Cisco iOS and ARP table on Windows operating system. Guys, in Windows operating system, PC is not going to store their own entry, right? But in the Cisco operating system, it is storing their own entry as well. Like my IP address is 10.1.1.1 and my MAC address is this one. Clear? In the Windows operating system, here you can see on PC0, check PC0 ARP table. There is only one entry, right? MAC address of PC4 means destination device. Is there their own entry? No. Windows operating system, in the Windows operating system, devices are not going to store their own information in ARP table. But guys, in Cisco operating system, it is storing their own information as well in ARP table. You can see this is ARP table of PC1. It have one entry. It has one entry, right? Their own entry. Now I am going to configure IP on PC3. So go to again interface 0/0, say no such, and IP address 10.1.1.2 So IP interface brief. Okay. Now so IP ARP. Yes. Yeah. Please ask. Yeah, these PC are routers. Just consider it as a PC. These are router. Okay. So guys, see the ARP table of PC1. Can I ping to PC3? Yes. Ping 10.1.1. Yeah. No, I am using router as a PC. I am using router here as a PC. Just assume this is PC where Cisco operating system is running, not Windows operating system running there. That's it. So guys, if I will ping 10.1.1.2 and this IP address is the IP address of PC3, tell me the process what will happen. First PC1 will generate ARP request message or ICMP request message. First it will generate. Why ICMP, brother? This PC don't have MAC address of 10.1.1.2. Destination MAC address is unknown. Destination MAC address is unknown. See, even I can capture this link to show you the packet, right? So I'm going to capture, let's say E0/2 interface. I have capturing, that means I can see all data on the link, right? And now let me do one thing. Let me remove the IP as well so that I can show you gracious ARP as well. Go to interface F0/0 and say no IP address. I have removed the IP address. I have removed the IP address. Which PC is sending gracious ARP 10.1.1. To duplicate IP address? Do so IP interface brief. We don't have IP here. So once I will say IP address 10.1.1.1 255.255.255.0. What will happen? It will generate a gracious R first. Are you able to see the gracious R packet of PC1? 10.1.1.1, this one. Source MAC is the MAC address of PC1, destination MAC is broadcast. And guys, source IP is the IP address of PC1, destination target IP address is same. In the gracious ARP, source IP, destination IP both are same. Means who will generate reply? If there is any machine who is using this IP address, right? If no one is using this IP address, then no one is going to generate reply. Then in the next step, now it have checked the gracious ARP. Why PC2, PC3 IP address is duplicate? I think you know other PCs have already IP address in this scenario like PC2. Let me do one thing. Let me check IP on PC2. Yes, here also you can see I'm getting same message. Which message? Duplicate address 10.1.1.2 on fast Ethernet 0/0. Actually right now I have configured same IP on two devices, on PC3 also and PC2 also. So both devices are giving you this log message, right? And how these devices are getting about the duplicacy, guys? With the help of gracious ARP, correct? So on the PC2 I am going to change IP. Interface F0/0 or say no IP address for now. I have removed the IP. Now we don't have gracious ARP message here. Okay. Now the next step, where is capturing? Now you can see we don't have any gracious ARP on link. Now second step, I am going to ping 10.1.1.2. What will happen? First it will generate ARP message, right? Are you able to see ARP message here? From, yeah, PC1 to PC3. 10.1.1.1 to 10.1.1.2. This is 10.1.1.1. This is 10.1.1.2. So I am pinging 10.2 from 10.1. Huh? Both are in same network. So once I have ping 10.2, guys, see, first of all, this PC have generate ARP request. So it is asking who has 10.1.1.2, who has this IP address, tell to 10.1.1.1, right? And PC1 will generate this request message, and PC2 is going to generate what? Reply message. In the reply message, it will see here MAC address. So you can see the next packet, ARP reply message. Who is sending 10.1.1.2? And what is the MAC address of 10.1.1.2? This one. And after that, you can see the ICMP packet. Source 10.1.1, destination 10.1.1.2, right? So until and unless PC1 will not have destination MAC address, it cannot send any data. So first of all, destination MAC is required. So every time PC is going to check their ARP table, so IP ARP. If MAC address is not available for the destination IP address in ARP table, then it is going to generate ARP. But when I will ping next time, ping 10.1.1.2, will PC1 generate ARP? No. Why? Because entry is already there. Here is the MAC address of 10.1.1.2. So this PC can encapsulate the data. How? See, now PC1 have now information that my IP address is source, that is 10.1.1.1. Destination IP address is this one, 10.1.1.2. Source MAC is MAC address of PC1. Destination MAC is available in the ARP table, this one. Yes or no? So it can encapsulate the packet. Now guys, see, ping is working. Now go to switch 1. And on switch 1, see, show MAC address table. So MAC address table. See, how many MAC addresses are there? MAC address of PC1, PC2, PC3, PC4. So it is learning one MAC address on 0/2 interface. This is the MAC address of PC1. On 0/3 interface, this is MAC address of PC3. So total number of MAC address in the MAC address table is 5 till now. Done, guys? Huh? PCs are? Yeah, PC is forwarding traffic to switch, and when switch is receiving traffic on their interface, it is learning source MAC. So we have 5 number of MAC addresses in the MAC address table, and this switch have learned these all MAC addresses dynamically, right? So guys, there is one timer for these MAC address. So MAC address table is in time. So what is time? 300 seconds. That means this switch is going to remove MAC address from their MAC address table after 300 seconds. So always keep in mind, show MAC address table. So MAC address table. So see, if this switch will not receive any traffic on 0/3 interface for 300 seconds, then it will remove this entry. Clear? Even you can increase the MAC aging time, brother, no problem. Even you can increase for a particular VLAN as well. But is these entries are, guys, permanent? No, right? That means if there is no entry, then what is the problem? Problem is a non-unicast plotting, right? Problem is a non-unicast plotting, because if MAC address is not there in the table, then switch is forwarding it from all their interfaces, correct? This is lab, guys, in the simulation software, but in the production network, in the real-time network, you will have lots of devices. 500 number of devices. So switch will forward one copy of icmp or R to 500 devices every time whenever the switch don't have MAC address in their table. So this is not true. Here what we can do, we can increase the MAC address, MAC addressing time. But the other option is we can create the permanent entry. We can create the permanent entry, like you can see the MAC address of PC1 is, what is the MAC address of PC1 guys? PC1 is connected on 0/2 interface, 0/2 this one, right? This is MAC address of PC1. So simply I can say to this switch MAC address table static, and then tell me the MAC address, this MAC address on which interface. Okay, first define the VLAN, let's say VLAN 1, we will talk about VLAN later, and then on which interface you want to bind this MAC address. So on interface E0/2, yes or no? Correct guys. So I have configured now this MAC address on 0/2 interface manually. This is a static method, and now this entry is going to be permanent. So MAC address table. So are you able to see the static entry here? On 0/2 interface there is one static entry, and guys there is no timer for this entry. So even I can check like this also. So MAC address table static, show me the static, so it will show you the static only. If I will say show me the dynamic, then it will show you dynamic only, right? And even I can clear MAC address table, clear MAC address table dynamic, right? So MAC address table, still we have dynamic MAC addresses. Don't know why it's not working here. Is it this is, now you can see we have only one MAC address in the MAC address table, right? Again it will receive traffic. Actually switch is receiving multiple types of traffic from these devices, from end devices, right? These end devices are sending keep alive message to check the neighbor is alive or not, huh? So yes, one port can learn multiple MAC address, but that is not. See, in my scenario, here we have lots of devices. So switch one, and we have only one link. Just forget about the upper link. So switch one is going to learn how many MAC address on 0/0 interface. MAC address of PC2 also, 4 also, this PC also, this PC also, this PC also, right? Switch 1 is going to learn MAC address of all the devices connected to switch 2 on 0/1 interface only, right? So in this scenario, switch 1 is learning MAC address of PC2 and PC4 on the same interface. Getting what I am saying here, on switch number 2 I have two devices, PC2 and PC4, and between switch 1 and switch 2, suppose we have only one link, this lower link 0/0. So switch 1 is going to learn MAC address of PC2 and 4 or on which interface? 0/0 interface. Because when PC2 will forward traffic to PC1, let's say, it will forward to switch 2, switch will forward it from here. On switch 1 will receive traffic on 0/0 interface. First it will learn what? Source MAC. Source MAC means MAC address of PC2. In the same way, MAC address of PC4, it will learn on same interface. Like I have switch 1 here, which is connected with switch 2, and then here I have lots of PCs. PC1, 2, 3, 4, and here I have PC5. So switch 1 is going to learn MAC address of these all devices guys on single interface, on this interface. Yes or no? So if someone will ask you, can switch learn more than one MAC address on single interface? Yes, of course. Okay. Then if you want to increase the MAC aging time, simply you can type command MAC address table aging time, and then you can set aging time, guys. Even you can set time 0. 0 means disabling aging time. So if I will configure aging time 0, that means I am telling to switch, please do not remove any MAC address. Is it good or bad? Is it good or bad, guys? If I will disable the MAC aging time, is it good? Just bad. Why bad? Yeah, let's suppose in the real time here I have 100 number of devices, here also have 100 number of devices, and even 50 devices are not communicating, right? 50 devices are not communicating with each other, but still both switches will have entry for 50 PCs in their MAC address table. Unnecessarily it is going to maintain the entry, right? That's why we have MAC is in time. So if any PC is not communicating, please remove their MAC address from table, right? So we should not disable it. Again, suppose here I have one server, and outside user from the internet are accessing this server, right? Lots of my employees are accessing this server. So should this switch learn MAC address of server dynamically? No, because see again, if this switch don't have MAC address of server in their MAC address table, then it will perform a non-unicast flooding. And as we know, we are receiving lots of traffic for servers, so we will do the static binding for the server, right? My God, what I'm saying, if I have some resources in my network, right, and that resources is accessible from multiple people, right? Multiple employees from the multiple remote users are accessing that server. So if you are getting lots of traffic for a particular device, then you should configure a static MAC address of that device on switch. Why? So that switch cannot perform a non-unicast flooding. Because let's suppose this switch have received one traffic for the server, right? So it have learned the MAC address. Now it have not received any packet for server for 300 seconds. So it is going to remove it. After 300 seconds, another people is going to access the server. Again, switch will perform what? A non-unicast flooding. Yes or no? So as I know, we are receiving lots of traffic for server. I will configure the static method, right? So everything is in use, guys. We are also configuring manually. We are also binding the MAC arrays with interface manually, right? Statically for the permanent entry. But for which kind of devices? For common devices like servers, maybe for printers. So whatever devices you have, and which are accessible from all employees, and all employees are accessing that device, right? If you are getting traffic for lots of traffic for a particular device, then you should configure what? A static binding for that device. And dynamic is good for general employees, right, who are communicating with each other. Let's say I am here on switch number 1, I'm here on switch number 1, and manager is here on switch number 2. And guys, this is me and this is manager. Me and manager are communicating hardly sometime. Let's say after 5 days or after 10 days we are sending one letter, right? I'm sending one letter to manager after 10 days. So should I configure my MAC address statically on switch? No, because switch should not learn my MAC address, should not keep my MAC address information every time in their MAC address table, because rarely I am sending traffic to switch. So it is better switch will perform what? a non-unicast threading when I will forward the traffic, because there is limitation of MAC address table as well, guys, right? As switch have memory, and if it is storing MAC address in their MAC address table, means it is using the memory. So there is chance that memory get full, yes or no? So if memory get full, then what will happen? It cannot learn the new MAC address, brother. Let's say this switch have capability to learn only 100 MAC address, and you have 200 devices over here, right? So again 200 devices can communicate with each other, but you have to configure the switch in such a way so that it should not store MAC address of a single device for long time, right? Getting my point? I will reduce the MAC address in time. Means if PC1 and PC2 are communicating with each other, switch have MAC address. Maybe it is going to store it for next 100 seconds. After that, it will flush it, right? So do you want to see how many MAC addresses this switch can learn, guys? So MAC address table count. How many MAC addresses this switch can learn? Okay. But guys, in real time, you will have lots of switches. Let's say you have 100 number of switches in the building, in the big building. And on each switches, let's say 50 users are there. That means how many total number of users are there? 500. 5000, right? 5000 users are there. That means switch need to learn MAC address of 5000 devices. And just assume that switch don't have capability to learn 5000 MAC addresses at a time, because this is my device. Right now I have allocated more memory to store MAC address. That's why this switch is able to store this much amount of MAC addresses. But let's say I need some memory for other purpose, for VLAN. So I can decrease the memory for MAC address table. I can allocate more memory for other purpose and less memory for MAC address table. This is not fixed that we have defined the fixed amount of memory to store MAC addresses. No, we can increase the space for routing, we can increase the space for switching. It totally depends on us, how we are using the device. Let's say I'm using this device only for switching, then definitely I will increase the memory for storing MAC address. What? Switch is hardware, and switch has operating system. You have installed the operating system, that's why you are able to use it now. In the operating system, it is maintaining MAC address table. Like here I can create the VLAN also, so I need memory for VLAN. I can, let's say, configure the routing protocol, so I need memory for routing protocol as well. So we can manipulate the memory. We'll see these all, brother, don't worry. We have a topic, separate topic on it, how to allocate memory on these devices, don't worry. But right now this switch can learn this much amount of MAC addresses, and right now this switch have how many dynamic MAC address, guys? 5. How many static MAC address? 1. Total number of MAC address in the table is 6. Getting my point? Yes. Total MAC address. Yeah, after some time it is going to flush it now. Again, it will, when it will receive the traffic, it will learn again. Getting my point? If I will ping to PC1 to, let's say, PC4, again it is going to learn all MAC addresses. Correct? And so MAC address table aging. This is by default time, 300 second global timing. Global time is, it is for all VLANs. So if you want to change it, say MAC address table aging for VLAN 1. Okay, time, let's say 100 second, and then for which VLAN, let's say for VLAN 1. So MAC address table aging time. Now you can see what is MAC aging time. 100 for which VLAN? For VLAN 1. But again guys, global MAC address is what? 300 second. Means for rest VLAN, still aging time is 300 second. For VLAN 1 users, MAC aging time is 100 second. Right? This is how we are using it in real time. So let's say we have servers in VLAN 10. So I will increase MAC aging time for VLAN 10. Right? So that switches should keep MAC addresses of server for long time, and it should flush the MAC addresses of general employees shortly, maybe within 3 seconds. Is real time use clear guys? Tell me yes or no. Where I am going to use it in real time. This is basic function of switch. Until and unless you will not understand these things guys, I cannot make you understand the switching protocols. So to be honest, tell me frankly, is it clear to all? See, don't worry about the command guys, what command I am using here, right? Just see the output only, because I have everything planned for you. I am going to share all configuration, I am going to teach you the configuration as well, right? But not now. Now I am just trying to make you understand the function, basic function of switch, how switch is working. So just see the MAC address table, not focus on command, because I will give you the command in last. Now you know what is MAC address table. You need what command to check MAC address table. Don't worry, you can even find command on Google. But first understand what is MAC address table and how switch is building it. So we have two options, right, to build MAC address table, static or dynamic. In static, manually you are going to bind MAC address on interface. In dynamic, whenever switch will receive frame on their interface, it will learn source MAC address. That's it. Yes or no? Yes or no? So MAC address table, and then you can see we have option, we can say static, so in the static entry, then we have option to check like this, we can say dynamic, so it will show you dynamic entry. Even we can run command like this, so it will show me all MAC address, static as well as dynamic. Then under the VLAN also we can check, like let's say I want to see MAC address under VLAN 10, so you can see we don't have any MAC address in VLAN 10, right? In the VLAN 1 we have these MAC addresses, so I can filter it like this also. These are just a command, don't worry about the command. Then even you can check MAC address on a single interface, like I want to see switch has learned what MAC address on interface E0/2, so you can see this MAC address, so I can run command like this. Because guys, in real time, you know, if you will run this command, so MAC address table, so MAC address table, you will have thousand number of entries, right? So you want to find the MAC address on a particular interface, let's say for troubleshooting. In upcoming day, you will see how we will troubleshoot this type of issue. So maybe you need to find the MAC address on a particular interface, let's say on this interface. Like you want to check the switch is learning correct MAC address on this interface or not. Or let's say, let's suppose PC1 and PC2 are not able to communicate with each other. So you have received the ticket that PC1 and PC2 is not able to communicate with each other. So what you need to check on switch number 1, switch 1 should learn MAC address of PC2 on 0/0 interface of switch 1, right? So you can check what MAC address switch is learning on this interface. How? Simply you can run command show MAC address table, then interface, and E0/0. It will show you the MAC address on this interface, right? So these are troubleshooting commands. We'll use it later. Okay. Then we can use address command as well. Like if you have address, like I know the MAC address of, let's suppose I have one MAC address, this MAC address, and I want to know the switch is learning this MAC address on which interface. So I can run this command. So MAC address table and this address. So it will show you the interface. This MAC address is learned on 0/0 interface. Getting my point? So if you have MAC address, you can check the interface. If you have interface, you can check the MAC address, right? Because in real time, we are to check MAC address table, we will not run this command, so MAC address table, because there will be lots of MAC addresses. Clear? Then guys, MAC address table, and yes, to configure a static, here I will add the static keyword, then we can define the MAC address, then VLAN, and then interface. Clear? Tell me so that I can move to next device, that is router. Edge switch function clear, guys? Right? No, see, we have two link between switch 1 and switch 2, but still one link is active, one link is backup. One link is active and one link is backup. If you will access switch 1, so here you can check, so span tree command. See, all ports are in forwarding state here. All ports are in forwarding state. But guys, on switch 2, see, on switch 2, so which command? Spanning tree. See, 0/1 is blocking. Correct? 0/1 is what, guys? Block. Right? So this link is blocked. So switches is not going to use this link to forward user data. If lower link will goes down, then automatically this link will come up. Right? So one is for backup between switch 1 and switch 2. If see interface is 0/0, if this interface, if I will shut down this interface, and now if you will run same command, you can see now 0/1 is in listening state. Now this port is coming in forwarding state. After 30 seconds, this port will come in forwarding state. I have shut down it. I have downed it. I have run command shutdown. So 0/1 will come in forwarding state. If both are up, then lower link will be in forwarding state, upper link will be in blocking state. Blocking means it is the backup link. Now you can see 0/1 is your forwarding link. Again, when 0/0 will come up, say no shut. No shut means I am upping the port. Running no shut command means port will come up. Change state to up. Now you can again check. So spanning tree, you can see again 0/1 is what? Block, and 0/0 is coming in forwarding state. Yes. Yeah, switch 1 have already knowledge that 0/E is block. Actually, you know why switch 1 will not forward traffic from 0/1 interface? Tell me, guys, just use your mind. Tell me why switch will not forward traffic from 0/1? Because no blocking. Because switch 2 will forward traffic of PC2 from which interface? From the forwarding state, from this interface, right? This interface is block, right? Means switch is not going to forward, switch 2 is not going to forward any traffic from this interface. Correct? So if switch is forwarding traffic from 0/0, that means switch 1 is going to learn MAC address on which port? 0/0 port. Right? So switch 1 will learn MAC address of PC2 and PC4 on 0/04 port. Let's say PC2 MAC address is 0B, PC4 MAC address is 0C. So in the MAC address table of switch 1, there will be entry 0B MAC address, exit interface 0/0. for 0C MAC address, exit interface 0/0. So if switch is receiving a frame where destination is 0B, it will forward from which interface? From 0/0 interface, not from 0/1 interface. So switch 1 is never going to forward traffic from 0/1 interface because it will not learn any MAC address on 0/1. Clear? Is it clear now? Right? So port is blocked on switch number 2. Because of this, switch 1 will learn all MAC address on 0/0 interface. All MAC address of those devices which are connected with switch 2. Hope this is clear. Any other question? Anything else? Anything else? No? No, in the real time, definitely depends on the scenario. Let's say switch 1 is on the switch 1, I have one server, right? This is, let's say, HTTP TP server. That means this is my web server. And switch 2 is connected with one router, just suppose, okay? And this router is connected with internet, just suppose, and outside users, or this internet is connected with one my remote branch, let's say somewhere else, right, in US. And remote users and outside users, these all users are accessing this server multiple time in a day, right? Means I'm getting lots of traffic for server. So tell me, here between switches I need to increase the throughput, right? Suppose I have only single link, single Ethernet link. So bandwidth is 10 Mbps. 10 Mbps. So guys, if one user is forwarding 1 Mbps traffic, then how many user can access server at a time? Only 10. Because between switch 1 and switch 2, we have only 10 Mbps. And one user is sending 1 Mbps traffic to my server. So only 10 users can access the server at a time. But I want 100 users should be able to access the server at a time. What I need? I need to add multiple link over here. But again, if you will add multiple link, then switch is going to block it. So you will bundle it. You will combine it with the help of protocol. Right? So one link is giving you how much bandwidth? 10. So total how much bandwidth you have? 30. Still 30 user can access the internet. So maybe you can replace the cable or you can add more link between switch 1 and switch 2. So it totally depends on the scenario. Okay guys? Okay. Let's say we are connecting lots of my end employees together through these switches, then I need less bandwidth. But always keep in mind the link which you are using between switches are shared link. Like let's say I have switch 1 here and then switch 2 here. I have one link that is Ethernet link, let's say, right? That means 10 Mbps, right? And here I have one user, here I have user, here I have user. So let's suppose we have 100 number of user. So guys, link between switch 1 and switch 2 is shared link for all 100 users. Yes or no? Bandwidth of this link is 10 Mbps. Bandwidth of this link is 10 Mbps. So this device can send 10 Mbps traffic to switch 2. Switch 2 can also forward 10 Mbps traffic to switch 1. But can switch 2 forward 20 Mbps traffic to switch 1? No. Right? So link between switches should be good. Or you can use multiple links to increase the throughput. Why? Because link between switches are shared. But this link is not shared. Only this PC are going to use this link, right? This link is not shared. Only this PC is going to use this link. But link between switches is shared. Getting my point? So if I have 100 number of devices and we have 10 Mbps link, so can you tell me one user will get how much how much bandwidth between switches? Hmm? 10 Mbps. We have total 10 Mbps and I have 100 number of users. If I have 10 users, then each user will get 1 Mbps link, around 1 Mbps, right? But we have 90 more users. That means one user will get less bandwidth, right? So if those all computers will communicate at the same time, definitely you will see the congestion on this link, right? Users will get latency, delay issue. Users will face delay. So you need to increase the bandwidth between switches, okay? So it is not sure that every time you need to use two link. You can have more than two links also, and you can have one link also. Yes, based on scenario. Let's say this is one building, and guys, in my building there are multiple floors, right? At each floors there are, let's say, 20 computers, 20 PCs, 20 PC, 20 PC, 20 PC, 20 PC, and 20 PC. So I need to connect these all 20 pieces together at each floor. I need one switch at each floor, yes or no? Right? Now through switch I can connect 20 computer, right? And now it's totally depends on our requirement how you are going to connect these switches together, right? So you will calculate the bandwidth requirement between switches, and according to that you will add the cable. Clear? Now next device is router, guys, but today we don't have time to start router. So what we'll do, we'll start router tomorrow, but hope switch is clear. Switch function is clear. First function of switch, learning MAC address. Second function of switch, forwarding traffic on the basis of destination MAC address. So switch always learn source MAC address, and on the basis of destination MAC address it takes forwarding decision. Forwarding decision means from which interface I am going to add this frame. I am going to exit this frame. Clear? Can I close this lab? Any question, guys? Anybody? If anyone have any question, please ask. Please ask. I'm requesting you, brother, because after the training, you are going to attend lots of interviews, right? Interviewer can ask you any question, and I will be not there, right, on call. So you cannot ask to me that time. So that's why I'm telling you again and again, please ask the question. Whatever things is coming in your mind, please ask. Everything should be very clear and crystal from day 1 to day 60 or day 70 or day 80. Then only you can crack interview, right? So let me ask you some questions, guys. What is by default packaging time on Cisco devices? 300 second. Can we change it? Okay. What is the meaning of packaging time? Packaging time means keep the MAC address for how long? For the configure packaging time. Correct? If packaging time is 300 seconds, that means switch is going to keep one MAC address in their table for 300 seconds. Right? How many way we have to configure MAC address table or to build MAC address table? Two, static and dynamic. So how by default switches learn MAC address? Dynamically. Dynamic. Yes. And what is switch? to connect multiple networking devices together. Yes. And how switch forward traffic with the help of MAC address. And guys, MAC address is layer 2 address in OSI model. MAC address is layer 2 address, data link layer address. So that's why we called switch is a layer 2 device. What we call switch is a layer 2 device. What is the see, interviewer can ask you even this question also, why we call switch is a layer 2 device. So most of the people are saying switch works at layer 2. That's why we say switch is a layer 2 device. Is it true? No. Switch forward traffic on the basis of layer 2 information, right? Yes. Switch forward traffic on the basis of MAC address, and MAC address is layer 2 address. So that's why we said switch is a layer 2 device, because switch forward traffic on the basis of layer 2 information, or you can say switch forward traffic on the basis of MAC address. That's why we call switch is a layer 2 device. So now new definition is, what is switch? Switch is a layer 2 device which is used to connect multiple computers together. Switch maintain MAC address table to forward traffic from one interface to another interface. By default, MAC aging time is 300 seconds, right? And switch learn always source MAC address. So if anyone is asking you what is switch, answer should be this one. Not only switch is a networking device which is used to connect multiple computers together. Also include these all points. Okay? And hope why it is layer 2 device is also clear. Right? Multicast device means no, this is not true. Switch have capability to do unicast, multicast as well as broadcast. Switch can do all type of communication, right? We will see how switch will perform multicast. Today we have seen how switch perform unicast and broadcast. Yeah, hub is layer 1 device. Okay, so guys, and like switch is used to connect multiple networking devices together, router is a device which is used to connect multiple network together. Router is a device which is used to connect multiple network together. So let's suppose I'm designing one network for a company. Is my screen visible again? Let's say I have one switch here, and through this switch I've connected lots of computers. Or maybe I have multiple switches here, right? And multiple devices are connected together. And in the next building, or at the different location, again we have some computers and I need to connect them all together. Again I need a centralized device, that is switch. Through switch I can connect like this, right? Now guys, I have two LAN, two local area network, yes or no? This is, let's say, LAN 1, and this is what? LAN 2. Now to connect these two different network together, you need layer 3 device, that is router. Now in the next class we are going to understand which table router maintain to forward the traffic, like switch maintain MAC address table, and how router is going to forward traffic from one interface to another, like switch is doing. Clear? And after that guys, after router, firewall. Again in firewall, what table firewall is going to use to forward the traffic, and how firewall is forwarding traffic from one interface to another. That's it. Clear? So we will meet now tomorrow. We will discuss router, and after that maybe I will start IP addressing or OSI model. Okay, hope class was helpful.